and I are just a small speck of dust in the universe, but carry the sparkling beauty of the stars here. Perhaps the most interesting thing about the universe, every time we look up at the night sky seeing those distant glimmering lights, we cannot help but admire that they have shaped religious culture and the advancement of science even on a clear night. When you find a place far away from city lights, you can only immerse yourself in the night sky with about 3,000 stars. Most of them are lonely. We have learned about the greatest celestial bodies before the energy that makes these stars comes from the interactions between atoms. So to understand the largest celestial bodies in the universe, we have to start with the basic atoms. When a star's life ends, those basic principles will come into play again to predict what will happen to it in the early universe when no stars were formed. Only two elements existed, hydrogen and helium. After the first stars were born, they began to convert hydrogen into helium through nuclear fusion, the same process that the Sun is doing today when these stars die and leave the main sequence. They begin to use helium to create heavier elements, like carbon. Nitrogen, oxygen, silicon, iron, giant stars, when they are nearing the end of their lives, will explode and become bright supernovas that release these heavy elements into space. Some of which will be captured by the stars, newly formed, absorb this process, just like humans are born. Go away and die. Stars are formed from giant, magnificent, molecular clouds with fog-like shapes. How can such loose molecular clouds become dense enough stars to fuse hydrogen into helium? Gravity plays a big role in this. British astronomer James Hopwood Jaynes calculated the largest mass a molecular cloud can reach before it starts to collapse, due to gravity. Astronomers call this the Jaynes mass, and it depends on the temperature and density of the cloud. Molecular cloud collapse is often triggered by external events such as the merger of two molecular clouds increasing their mass beyond the Jaynes mass, or a shock wave from the explosion of a nearby star hitting the cloud, causing it to shrink further and continue to collapse under the influence of gravity. As it collapses, the molecular cloud breaks up into smaller parts. These regions, called protostars, begin to spin at an increasingly faster rate, like an ice skater pulling his arms in as he spins. The temperature and pressure in this region increase until this rapidly rotating ball of gas begins to convert hydrogen into helium, and a star is born. This process lasts hundreds of millions of years. In the winter night sky, there is a very recognizable constellation, the constellation of Orion. It resembles a hunter holding a shield and weapon with 3 stars crossed at its belt, and 4 bright stars surrounding it, forming the main body below the belt of the constellation. Orion, you can see the cradle of the newborn stars, can be observed with the naked eye. Around these young stars, there are also dark and flat disks of gas called protoplanetary disks. Astronomers believe that these disks, under the influence of gravity, will form the first planets. As the stars get older, they consume more hydrogen. One day, the rate of nuclear fusion will slow down, causing the core to not be able to generate enough energy to counteract the force of gravity. The core will contract, the temperature will increase, and the fusion rate will increase. This is a cycle that main sequence stars have been going through. Our Sun has been in this phase since its formation. This is what the Sun looks like when it becomes a red giant. It looks incredibly scary. Try to imagine it from Saturn's perspective. Suppose the Earth's orbit remains unchanged, and it maintains its current distance from the Sun. The seawater, at such high temperatures, will start to boil, and our home will become a scorched earth with no life. The Sun that gives life to all will eventually become the one that ends all life. About 5 billion years from now, the fusion reactions in the core of the Sun will stop completely. Its core will contract rapidly, marking the departure from the main sequence. In the He-Sprung-Russell diagram, when the outer shell of the red giant dissolves, the Sun will become a white dwarf with a mass of only about 54 pH, its current mass. This means the orbits of the planets and asteroids in the solar system will gradually expand outwards due to the lack of energy to maintain the temperature of the white dwarf, which will stop nuclear reactions and gradually lose heat over time, becoming a black dwarf. At that time, the entire universe will only have dust and gas left, the black hole. And when celestial bodies move, the black hole will swallow most of the matter. The proportion of black holes in the universe will increase over time. The protons will decay, and all matter outside the black hole will be converted into light energy or elementary particles. At that time, the universe will only have black holes. However, due to the phenomenon of H.W. King radiation, the black holes will gradually evaporate, lose mass, emit light and heat, and eventually the entire black hole will disappear. At that time, the universe will only be nothingness. Energy and matter will be evenly distributed, and entropy will reach its maximum value. The universe will be in a state called heat death. But when you hear this, don't let it discourage you, because the heat death theory is not the only reasonable hypothesis, and it itself has many incomplete points. Although every star will go through the process, nuclear fusion is like wrinkles, also fade. Heroes also grow old, talent will fade, wealth will also disappear. But the efforts, the brilliant moments we have experienced, do not need eternity to prove their meaning to us. Now, this is the best time to be alive. We are living in the most beautiful stage of the universe. There is a giant cloud in the universe, hundreds of light years away from Earth. Some areas of it are hiding dozens of unborn stars, while others are torn apart by reverberating rays. Space here is filled with deadly ionizing radiation, along with red-hot hydrogen filaments and vortices of matter capable of swallowing whole stars. This is where new stars are born, a stellar nursery near Earth. What is it hiding from us? There are many stellar nurseries scattered throughout the galaxy. Some are modest in size, while others span dozens or even hundreds of light years. These are vast nebulae made of interstellar gas and dust, compressed by gravity. Fascinating, most of these giant clouds are barely visible in the abyss of space, but some of them can be seen from Earth with the naked eye. One of these structures is the Orion Nebula 1344, light years away from Earth. It is the central object in the sword of the constellation. Orion, a clear straight line formed by three relatively bright light sources due to its large size and relatively close distance to Earth. This nebula has fascinated scientists since the early days of astronomy, so it is no surprise that this great structure is one of the most thoroughly studied space objects. The Hubble Space Telescope sent back the first images of the Orion Nebula in 1993, where its rich variety of colors was appreciated. Most of the material is red or bluish-purple, while the unusual peripheral regions with bright green lines were revealed through spectral analysis. This phenomenon has puzzled scientists for a long time because of the radiation they observed did not correspond to any chemical element known at the time. Even a hypothesis was put forward for the existence of a hypothetical element called nebulium, which was thought to be absent on Earth but was widely distributed in space clouds. However, with the advancement of science, it was discovered that the light was emitted by extremely dilute ionized oxygen. This discovery not only explains the strange light of many nebulae, but also that of the Sun. At present, at least 3,000 stars have been discovered in the Orion Nebula, along with huge interstellar gas clouds and a large number of protostars. All this great diversity of space objects concentrated in a region about 23 light-years in diameter, where they constantly interact with each other. The total mass of matter concentrated here is about 10,000 times the mass of the Sun, on closer observation of the Orion Nebula. We will notice some clearly defined regions that stand out the most. Among them is the trapezium, also known as Theta 1 Orionis. This is an open cluster of stars about 300,000 years old, consisting of 8 main components, some of which are binary stars, while others have no companions. The 4 brightest and most recognizable star systems in the trapezium are named after Latin letters located close together, in a region about 1.55 light-years in diameter. Each of these stars have masses between 15 and 40 times the mass of the Sun, indicating that they are very young and hot. Theta 1 Orionis C is the largest and brightest binary star in the trapezium, and indeed in the entire nebula, the blue-white main sequence star with a mass of about 40 times the Sun. The radius is 8 times that of the Sun. The surface temperature of this star is about 45,200 degrees Celsius, and its luminosity is about 250,000 times that of the Sun. The radiation from Theta 1 Orionis C illuminates most of the surrounding nebula, but there is almost no interstellar gas in the region, its immediate vicinity. This is because objects of this class often generate extremely strong stellar winds that push dilute matter away, traveling a few light-years away from the trapezium. We will see another notable system is the Tetra High Orionis. This system consists of 3 gravitationally bound stars located near the Orion Bar. A large feature of hot glowing gas, this area has long been impossible to study due to dense dust clouds. But thanks to the James Webb Telescope, more detailed images of this area have been sent back. The first component of Theta 2 Orionis is slightly less massive and not as bright as the largest star in the trapezium. Its surface temperature is around 34.7 degrees C. The second component of the system is 15 times the mass of the Sun and 12,000 times brighter. The third component is 5 times more massive than the Sun, with a temperature reaching nearly 13,700 degrees C. However, it is not only the bright stars that have attracted the attention of researchers. The James Webb infrared camera has allowed the discovery of previously unseen objects, hidden deep in clouds of gas and dust thanks to telescopes. About 180 celestial bodies called propytes have been discovered at the center of the Orion Nebula. These are dense and dark protoplanetary disks surrounding stars in the process of forming, one of which is Orion, 1024-606. About 13 years old, surrounded by a disk of gas and dust, about 300 astronomical units in diameter. Thanks to its position facing Earth, we can observe its structure and size. This star is expected to enter the main sequence phase in a few million years and will be accompanied by a system of many exoplanets and possibly their satellites. The night sky of these future celestial bodies must be a truly magical sight. Imagine a sky sparkling with colors, with the light of countless stars, much closer and brighter than what we see from Earth. Occasionally, giant glowing gas swirls cover half the sky, turns the night into a transparent twilight. If we fly a little further and observe a larger area, we will see that most of the nebula is filled with gas. The central part of the cloud contains ionized hydrogen, strongly absorbs a lot of high-energy radiation from stars. The temperature of this gas can reach 9,700 degrees, but decreases sharply towards the edges of the area. The contrast in temperature and pressure, as well as the collision of stellar winds, causes the matter in space to move, creating huge flows and vortices according to calculations. Some of them can reach speeds of up to 50 km/h, and their size can be larger than the solar system. Also, in some areas of the nebula, thin filaments stretching for light-years have been discovered, consisting of relatively cold molecular hydrogen, not mixed with methane, ethane, and water. Further, we will see that the central region of the Orion Nebula is surrounded by a gas cloud that is colder and denser than the bright stellar cloud and the light of the ionized hydrogen diansinen, a complex way of creating a beautiful, colorful light curtain. Behind it are hundreds of space objects invisible in the optical range, but the infrared cameras of modern telescopes allow us to see through the layer of interstellar matter by combining data from different sources. Astronomers have discovered about 1,700 protostars at different stages of evolution in this region. Their density is significantly lower than the central part of the nebula, due to the lower level of gravitational compression of the interstellar gas. Most of these objects are very young by cosmic standards and are still in the process of formation. According to modern concepts of stellar evolution, new stars are formed through the gradual gravitational compression of large interstellar gas clouds. Normally, this process causes giant nebulae to split into many gravitational centers close together and soon turn into protostars. These clusters are called stellar nurseries, or more scientifically, star-forming regions. At a certain point, the internal pressure of the compressed gas balances the gravitational force, bringing the protostars. The star enters a state of temporary equilibrium. The remaining matter swirls into a giant vortex disk, with some of it gradually being absorbed by the future star, and the rest being pushed away from the RH boundary of the star system. The young star's growing magnetic field also plays its part, as ionized particles accelerate through the magnetic field lines and then escape from the vicinity of the object. It has been calculated that such flows can reach speeds of up to 200 km per second, as they collide with the gas clouds around them, creating large vortices and hemispheres called Herbig-Haro objects. In the process, some of the kinetic energy is converted into light and heat, creating strange structures with different colors. In addition, the superfast movement affects the surrounding matter, creating shock waves that spread out, and these waves are also recorded by telescopes, as stellar nurseries contain many protostars located close together. Each star creates many gas streams, so it is not surprising that Herbig-Haro objects show an incredible diversity of shapes, shape, and color. They are essentially the result of a cosmic collision. They are very unstable and changeable. Haro-Heric objects change color and shape rapidly, and often completely vanish after a few tens of thousands of years. During this time, they travel 1 to 3 light-years on an orbit away from their parent star. About 400 such objects have been discovered so far, with the total estimated number in the galaxy being around 150,000. Perhaps one of the variations of this awe-inspiring natural phenomenon are bullets, hundreds of astronomical units in diameter, also discovered in the Orion Nebula. Moving at incredible speeds, they easily penetrate thinner hydrogen clouds, creating shock waves that spread far and wide. According to spectroscopic analysis, the front part of these objects contain iron atoms that glow in the infrared. These celestial objects, known as bullets, are estimated to be around 1 year old, and their origin remains a mystery. They may have originated from some cataclysmic event that continues their journey. We will soon realize that the Orion Nebula is part of a much larger cosmic structure called the Orion Cloud, which spans hundreds of light-years, covering almost the entire constellation. Orion in the Earth's night sky. This is where the famous Horsehead Nebula is located, which stands out for its strange shape. It is a dense dust cloud about 3.5 light-years in diameter, easily visible against a contrasting red background. Also close to the Orion Nebula is another impressive cosmic structure called the Barnard Ring. This emission nebula is about 300 light-years in size, formed about 3 million years ago, after a series of consecutive supernova explosions. After the gas streams were compressed by the shock wave, mixing them, creating a giant warp nebula and a cluster of many young stars, giving it a red color despite its beauty. The Orion Nebula is a fragile and unstable object by cosmic standards. Stellar winds and light pressure from the many young stars along with the gas streams and vortices. The chaos constantly disperses the object. Its matter into the space around the nebula has lost about 60 pH of its original matter, and in about 100,000 years it will lose the rest. Instead, there will be a similar to the Pleiades cluster. For a while young stars will form. It will move together, but eventually each star will find its own way through the vast space of the infinite galaxy, despite years of observation and modern equipment. James Webb has clearly demonstrated that we have yet to see the universe in all its diversity. Thanks to the images from the telescope, we have discovered that even the supposedly well-studied areas of the sky can hide unknown wonders. The deep, dark abysses of space always hide countless mysteries, and no one can know what will happen in the future. In the rim of the solar system, there is a small world covered in toxic ice, hidden in the vast abyss of space, where a giant darkness obscures the star, while the sun moves silently across the sky with its weak light. At the rays of sunlight here cannot dispel the dim darkness that covers the icy plains, where the terrain is cut by deep fissures. This is Pluto, a lifeless kingdom made of rock and ice. It is immersed in the darkness of eternity. Pluto is about 40 astronomical units from the Sun and is a dark object that is difficult to distinguish. This distant celestial body moves a long orbit around the center of the solar system, completing one orbit every 248 Earth years. We know that Pluto's radius is 1,108 km. This means it is significantly smaller than all the planets in the solar system, even some other satellites, including the Moon. At the same time, observations of the celestial body's proper motion have helped calculate its mass with high precision. This mass is very small, only about 1.3 nh10 to the 22 kelvins, equivalent to 18 mph. The mass of the Moon. It is easy to see that Pluto has many similarities with small celestial bodies such as Eris or Caecina, in terms of characteristics. This is also the reason why it was removed from the list of planets in 2000X due to its long and elongated orbit. Pluto has a very long orbital period, only until 1989. This dwarf planet has just passed perihelion for the first time since it was discovered. It is closest to the Sun at a distance of 29.7 astronomical units. Since then, this distance has been continuously increasing and will reach its maximum value in 2130. By that time, the dwarf planet will be near aphelion 49.3 astronomical units from the center of the solar system. So Pluto is a very distant and faint space object. That is why it cannot be seen from Earth with the naked eye. And even in images from the Hubble Space Telescope, this dwarf planet looks like a hazy brown disk without any surface details. Of course, in such conditions, studying the celestial body accurately is almost impossible to solve. The problem. This topic, the New Horizons probe, was launched to Pluto in 2006. It took 9.5 long years for it to reach its destination. On the way, it sent back detailed main images of Jupiter. It was not until 2015 that the spacecraft reached the main target of the mission. When it flew past Pluto, the spacecraft made about 400 observations, collecting more than 6 gigabytes of information, and it took more than 1 year to transmit this large amount of data back to Earth. Unfortunately, the orbit of the probe does not allow to take pictures of the entire surface of the dwarf planet. The reason is that New Horizons does not go into orbit around Pluto, but only flies by to be able to explore other space objects before going into the terrain. Features of this celestial body. We need to understand its internal structure according to the current model. Pluto has a large core with a diameter of about 1,700 km, consisting of a mixture of water ice and rock. This core is surrounded by a 300-thick ice mantle. There may be tectonic processes going on in the mantle, but they have not been thoroughly studied. This mantle is covered by a crust, which is a mixture of gaseous gases such as nitrogen, methane, and carbon monoxide. According to some hypotheses, Pluto's core may generate enough heat to melt part of the mantle ice, in this case deep below the surface of the dwarf planet. There may exist a very salty and toxic ocean containing large amounts of ammonia. The surface temperature of the dwarf planet is very low, not exceeding 60 decibels, equivalent to 213 decibels. Our exploration of Pluto will begin with its most prominent and well-studied feature, TBO Rayo. This large region is located at the equator of the dwarf planet and is shaped like a heart, giving it the unofficial nickname, the heart. Its size is up to 2,300 kilometers. It covers about 1/4 of the total surface area of the celestial body. The surface of Tomball Rio is heterogeneous. In the western part, there is a smooth and bright plain called Sputnik Planeta, with a diameter of 1,492 kilometers. The elevation map shows that this area is a large lowland covered by a thick layer of nitrogen pans, along with carbon monoxide and solid methane. These substances are bright in color, causing some parts of the plain to reflect up to 90 pH of light shining on it. There are also almost no impact craters here. This shows that this area is very young geologically. According to the main hypothesis, Sputnik Planeta formed about 100 million years ago when Pluto collided with a large celestial body, resulting in a giant impact crater that was filled with a hypothetical ocean inside the dwarf planet, which then rapidly froze. Some typical topographic features of the plain may be evidence for this. For example, there are quite a few smooth surface areas with sizes of 20 to 30 kilometers, with hills and depressions concentrated at the boundaries between them. This structure is similar to the convection zones that appear in any which fluid is heated from below. This may be indirect evidence for the hypothesis of a warm interior of Pluto. The radio tombs are surrounded by relatively high mountain ranges. To the west of the Nick Plania spot are the Hillary Montes, with elevations of up to 3,200 meters. To the south of the heart are the Tenzing Montes. Some of the peaks here are more than 6 kilometers above the average surface level of the dwarf planet, making it the highest mountain range found on Pluto. It is noteworthy that these rocks may be composed mainly of water, ice, and at low temperatures, like on Pluto, water ice is as hard as rock. Moving further south, we can see a deep basin surrounded by large ice and rock mountains. It is thought that this may be the mouth of an ancient ice volcano, and the surrounding rocks are frozen eruptions. Their chemical composition is of great interest in scientific research, because once known, we may have a better understanding of the composition of Pluto. The eastern part of the radio is darker, and its surface is covered with many impact craters, indicating that this area is much older than Nick Planeta. Moving further east along the island equator, we will see a series of dark spots hundreds of kilometers in diameter. These objects are called maculas and are named after dark gods of different cultures. For example, one of them is named Ba-Rock. They form a huge structure called BR Knuckles that surrounds the celestial body along the equator. The maculas are separated by high mountain ranges, and their surfaces are cut by deep fissures hundreds of kilometers. The macula is located west of Tumbo Rio, is the largest dark spot on Pluto with a size of nearly 3,000 kilometers. Its surface reflects only a maximum of 30 pH. The light that falls on it creates a sharp contrast with the nearby bright and light Sputnik play. There is still no exact information about the nature of the maculas. It is thought that their dark color is due to the function. The high amount of thins combined with the relatively high density of impact craters suggests that the maculas are very ancient. The surface of Fulu Macula is also not uniform. The western part has an undulating terrain. The central part is a smooth plain, and the eastern part is covered with mountains and impact craters, leaving the dark spot Cthulhu Macula. Let's face north. Here is the Low Rio, a large valley surrounding the north pole of Pluto. Surprisingly, this place is currently the most illuminated area on the surface of the celestial body. The reason is that Pluto's rotation axis is very tilted to the plane of the orbit, so in its motion, the North Pole is pointing towards the Sun. Pluto has some strange characteristics compared to other planets in the solar system. In addition to its orbit being significantly tilted to the plane of the ecliptic, the dwarf planet itself also constantly performs periodic oscillations. Near a certain point, this is due to the presence of a large satellite called Charon, which exerts a gravitational force on the dwarf planet. Mass. Charon's mass is 1.52 nh10 to the 21st power kg, which is more than 11 ph. The mass of Pluto, Charon, and Pluto are tidally locked to each other, always facing the same side towards each other. Unlike Pluto, Charon's surface is darker and has a lot of water ice mixed with methane and nitrogen. Only in some areas, apart from Charon, Pluto has a few other moons, but they are all much smaller and irregular in shape. Nix and Hera, discovered in 2000, are a few tens of kilometers in size, while Cabos and Styx, discovered later, are no more than 16 kilometers in diameter. All of these bodies are mostly made of water ice and may have been captured by Pluto's gravity from the Kuiper belt. Unfortunately, a large part of Charon is not in the view of the New Horizons probe's camera. But many interesting topographic features can still be found on its surface. For example, south of the equator, there is a large area called Vulcan Planum, with an area of at least 400,000 kilometers is equivalent to the average size of a country in Europe. The New Horizon probe is now more than 50 astronomical units away from Earth and occasionally sends back extremely important data until around 2030. All of its systems will gradually stop working, and the probe will be alone in cold space. Did you know that every second, trillions of mysterious particles pass through your body without you knowing? But these particles are called neutrinos, or also known as ghost particles. They exist everywhere, but hardly interact with any matter. They can even easily pass through the Earth. Scientists estimate that a single neutrino can pass through 1,000 dense blocks of matter after traveling 1 light year. So how was this mysterious ghost-like particle discovered, and what role does it play in the universe? In 1914, British physicist Chadwick discovered that during beta decay, matter lost a part of its energy in an inexplicable way. Although this loss of energy was very small, it violated the law of conservation of energy that is the foundation of modern physics. Some people even began to doubt the accuracy of this law. It was not until 1930 that Austrian physicist Wolfgang Pauli proposed a bold hypothesis that during beta decay, in addition to creating electrons, a type of electrically neutral particle with no mass was released, carrying the lost energy. In 1932, physicist Enrico Fermi named this particle the neutrino. However, because the interaction of neutrinos with matter is extremely weak, Pauli even thought that it would never be detected. After more than 20 years of effort, two American physicists, C and D, finally directly observed the neutrino in 1956 using a nuclear reactor. This discovery not only confirmed Paul's hypothesis, but also helped Rhines win the Nobel Prize. Nobel Prize in Physics in 1995. Today we know that neutrinos exist everywhere in the universe. They are created from the Big Bang supernova explosions and nuclear fusion in stars. For example, the Sun is a giant neutrino factory. During nuclear fusion at the core of the Sun, 4 protons fuse into a helium nucleus simultaneously releasing 2 positrons and 2 neutrinos. According to theoretical calculations, the Sun produces about 10 to the 38th power neutrinos per second, and about 60 billion solar neutrinos pass through each cubic centimeter of the Earth's surface per second. Although the interaction of neutrinos with matter is extremely weak, it is not impossible that for every 10,000 billion neutrinos passing through the Earth, one will collide with an atomic nucleus. In 1968, the American scientist Raymond Davis placed a 615-ton container of perchloroethylene solution 1500 members underground to detect solar neutrinos. When the particle chlorine-37 nucleus is neutrinoized and touches, it will transform into argon-37 by monitoring the amount of argon-30. Scientists can indirectly detect neutrinos. However, the experimental results were surprising. The number of neutrinos detected was only 1/3 compared to the theoretical prediction. This is the famous mystery about the disappearance of solar neutrinos. It was not until 2001 that this mystery was solved. The experiment of the Super Cameo Candy detector in Japan discovered that neutrinos can change from one form to another during the propagation process. This phenomenon is called neutrino oscillation. This discovery not only explains the disappearance of solar neutrinos, but also different cultures, for example. One of them is named Ba Rock. They form a huge structure called BR knuckles that surrounds the celestial body along the equator. The maculas are separated by high mountain ranges, and their surfaces are cut by deep fissures, hundreds of kilometers. The macula is located west of Tumbo Rio, is the largest dark spot on Pluto with a size of nearly 3,000 kilometers. Its surface reflects only a maximum of 30 pH. The light that falls on it creates a sharp contrast with the nearby bright and light Sputnik play. There is still no exact information about the nature of the maculas. It is thought that their dark color is due to the function. The high amount of thins combined with the relatively high density of impact craters suggests that the maculas are very ancient. The surface of Fulu macula is also not uniform. The western part has an undulating terrain. The central part is a smooth plain, and the eastern part is covered with mountains and impact craters, leaving the dark spot Cthulhu macula. Let's face north. Here is the Low Rio, a large valley surrounding the north pole of Pluto. Surprisingly, this place is currently the most illuminated area on the surface of the celestial body. The reason is that Pluto's rotation axis is very tilted to the plane of the orbit, so in its motion, the North Pole is pointing towards the Sun. Pluto has some strange characteristics compared to other planets in the solar system. In addition to its orbit being significantly tilted to the plane of the ecliptic, the dwarf planet itself also constantly performs periodic oscillations. Near a certain point, this is due to the presence of a large satellite called Charon, which exerts a gravitational force on the dwarf planet. Mass. Charon's mass is 1.52 nh, 10 to the 21st power kg, which is more than 11 pH. The mass of Pluto, Charon, and Pluto are tidally locked to each other, always facing the same side towards each other. Unlike Pluto, Charon's surface is darker and has a lot of water ice mixed with methane and nitrogen. Only in some areas, apart from Charon, Pluto has a few other moons, but they are all much smaller and irregular in shape. Nix and Hera, discovered in 2000, are a few tens of kilometers in size, while Cabos and Stick, discovered later, are no more than 16 kilometers in diameter. All of these bodies are mostly made of water ice and may have been captured by Pluto's gravity from the Kuiper belt. Unfortunately, a large part of Charon is not in the view of the New Horizons probe's camera. But many interesting topographic features can still be found on its surface. For example, south of the equator, there is a large area called Vulcan Planum, with an area of at least 400,000 kilometers is equivalent to the average size of a country in Europe. The New Horizon probe is now more than 50 astronomical units away from Earth and occasionally sends back extremely important data until around 2030. All of its systems will gradually stop working, and the probe will be alone in cold space. Did you know that every second, trillions of mysterious particles pass through your body without you knowing? But these particles are called neutrinos, or also known as ghost particles. They exist everywhere, but hardly interact with any matter. They can even easily pass through the Earth. Scientists estimate that a single neutrino can pass through 1,000 dense blocks of matter after traveling 1 light year. So how was this mysterious ghost-like particle discovered, and what role does it play in the universe? In 1914, British physicist Chadwick discovered that during beta decay, matter lost a part of its energy in an inexplicable way. Although this loss of energy was very small, it violated the law of conservation of energy that is the foundation of modern physics. Some people even began to doubt the accuracy of this law. It was not until 1930 that Austrian physicist Wolfgang Pauli proposed a bold hypothesis that during beta decay, in addition to creating electrons, a type of electrically neutral particle with no mass was released, carrying the lost energy. In 1932, physicist Enrico Fermi named this particle the neutrino. However, because the interaction of neutrinos with matter is extremely weak, Pauli even thought that it would never be detected. After more than 20 years of effort, two American physicists, C and D, finally directly observed the neutrino in 1956 using a nuclear reactor. This discovery not only confirmed Paul's hypothesis, but also helped Rhines win the Nobel Prize. Nobel Prize in Physics in 1995, today we know that neutrinos exist everywhere in the universe. They are created from the Big Bang supernova explosions and nuclear fusion in stars. For example, the Sun is a giant neutrino factory. During nuclear fusion at the core of the Sun, 4 protons fuse into a helium nucleus, simultaneously releasing 2 positrons and 2 neutrinos. According to theoretical calculations, the Sun produces about 10 to the 38th power neutrinos per second, and about 60 billion solar neutrinos pass through each cubic centimeter of the Earth's surface per second. Although the interaction of neutrinos with matter is extremely weak, it is not impossible that for every 10,000 billion neutrinos passing through the Earth, one will collide with an atomic nucleus. In 1968, the American scientist Raymond Davis placed a 615-ton container of perchloroethylene solution 1,500 members underground to detect solar neutrinos. When the particle chlorine-37 nucleus is neutrinoized and touches, it will transform into argon-37 by monitoring the amount of argon-30. Scientists can indirectly detect neutrinos. However, the experimental results were surprising. The number of neutrinos detected was only 1/3 compared to the theoretical prediction. This is the famous mystery about the disappearance of solar neutrinos. It was not until 2001 that this mystery was solved. The experiment of the Super Cameo Candy detector in Japan discovered that neutrinos can change from one form to another during the propagation process. This phenomenon is called neutrino oscillation. This discovery not only explains the disappearance of solar neutrinos, but also proves that neutrinos have extremely small mass. Japanese scientist Tak-Kik Kajita won the Nobel Prize in Physics in 2015 thanks to this discovery. Is one of the most mysterious elementary particles and the latest known to humans. Future research on neutrinos can bring about a revolution in the future. Physics even changes our understanding of the universe. If you drive a spacecraft into a black hole, what will you see? The closest supermassive black hole to Earth is Sagittarius. A star is 26,000 light-years away from us, with a mass 4.4 million times that of the Sun. However, its SWAT shield radius is only about 12 million kilometers before entering this distance. The first thing you see is the accretion disk of the Black Lake, the brightest part of the Black Lake. Here you will see many strange phenomena. For example, one side of the accretion disk is brighter than the other due to the Doppler effect. The image of the universe behind the black hole is bent around the accretion disk. Due to the gravitational lensing effect, the more distant stars have a slightly blue color, because the black hole bends space-time, making your time pass slower than the distant stars. As you continue to get closer to the black hole, the light in front gets stronger, while the light behind gets darker. This is the result of the aberration effect, showing that you are falling quickly into the black hole. At this time, the image of the black hole seems to shrink, and time on a distant spaceship appears to pass more slowly than the first boundary behind the accretion disk. Normally, all matter will be torn apart in the accretion disk. But if the ship can withstand the pressure and pass through the accretion disk, it will reach the photon sphere layer where light can orbit the black hole. When entering this area, all light will be swallowed by the black hole from the perspective of an outside observer. The process of approaching the black hole is endless, and eventually your image will freeze on the event horizon of the black hole. But in your subjective perception, you are still falling rapidly into the black hole. According to current laws of physics, scientists do not know what is inside of the black hole. But according to the theory of relativity, inside the black hole will fill part of the sky stars due to the aberration effect. The real part belongs to the vision of the black hole is only about 15 minutes, like the world seen through a fisheye lens. According to modern physics, the singularity in a black hole is a point of infinite density and infinitely small volume where space and time no longer apply the rules. Current physics cannot describe what happens after entering the singularity. Some scientists believe that the singularity may not actually exist, and entering it may take you to another space-time. Currently, apart from black holes, wormholes, and white holes, have not been discovered, although both are predicted by the theory of relativity. After 13.8 billion years since the formation of the universe, it seems that only black holes exist stably. The complex space-time environment that wormholes and white holes need probably only existed in the early stages of the Big Bang. The closest black hole to Earth is GBH1, about 1,560 light-years away, located in the constellation Ophiuchus. This is a stellar mass black hole, about 10 times that of the Sun. The discovery of GBH1 is significant because it is not only the closest black hole to Earth known, but also the first dormant black hole discovered in the Milky Way galaxy. Unlike active black holes, dormant black holes do not actively suck in matter, therefore does not emit strong radiation and is very difficult to detect. Scientists indirectly deduced the existence of GBH1 by observing the movement of its companion star. You are seeing the king of the rings in the universe, a super Saturn named J1407b. Its giant ring system has a diameter of 180 million kilometers, enough to connect the Earth and the Sun, compared to the rings of Saturn in the solar system, only 280,000 kilometers in diameter, and an average thickness of only about 10 J1407b is 200 times larger, completely changing the perception of astronomers about planetary rings located 434 light-years away from us. J1407b was not discovered by astronomers because its rings were too large to continuously obscure the light from the parent star. The 56-day cycle of brightness changes made astronomers realize that in this star system there must exist a giant object by analyzing the light curve and model computer simulations. Scientists speculate that this is a planet with a giant ring that causes this phenomenon when passing in front of its parent star, and this planet has been discovered. This is also the first exoplanetary ring system discovered by the transit observation method. The mass of J1407b is about 20 times that of Jupiter, surpassing the mass of the usual planet theory and becoming a strange celestial body located between the planet and the star. Some astronomers even believe that it has begun the process of weak nuclear fusion, passing from a gas giant planet to a brown dwarf star. But what makes astronomers more fascinated is its unprecedented ring system. Currently, more than 30 rings of different sizes have been discovered, forming a complex structure at a distance of 61 million kilometers from the center. Scientists also discovered a large gap, suggesting that a massive satellite may exist. There is a planet only 16 million years old. Astronomers believe that its rings are a special phenomenon in the early stages. In the next few million years, these rings will gradually coalesce into many large satellites. In the early solar system, Jupiter may also have many similar rings, then form dozens of its satellites by studying J1407b. Astronomers can better understand the formation and evolution of the planetary ring system as well as the mechanism of the birth of the satellite system. More importantly, if in the future a star without a planet is discovered, but the brightness still changes periodically, it is very likely that aliens are building a sphere. Star Tabi, 1480 light-years away from us in the constellation of Cygnus, is a typical example. Normally, the brightness of stars changes according to rules such as cyclical dimming due to planetary passage. However, Tabi's brightness changes very irregularly, sometimes suddenly decreasing by 22 ph. This phenomenon is extremely rare in known stars. Some scientists have put forward a bold hypothesis that around Tabi may exist giant structures built by alien civilizations such as the Dyson Sphere. This super-large structure can surround the entire star, collecting all of its light and heat to generate electricity or provide energy. This is a characteristic of a Level 2 civilization on the KDF scale. While humans are currently only at level 0.7, it will take hundreds of years to be able to exploit all of the Earth's energy and become a level 1 civilization. The distance to level 2 is still very far. According to theory, the habitable zone in the galaxy has at least 100,000 Earths. The planet you are seeing is the super-Earth. Kepler 22b, its volume is 2.5 times that of our Earth, only 600 light-years away. Its star is like the Sun, is a yellow dwarf star with an average mass, so astronomers believe that it is very possible for life to exist. On Kepler 22b is a symbolic telescope in the search for extrasolar planets. Kepler telescope, since its launch, has marked more than 5,000 extrasolar planets, including dozens of planets similar to Earth. At this rate, the number of 100,000 Earths in the Milky Way is too small. The number of second Earths in the entire universe is possible. There are more than the total population on Earth today, so much so that each person can own an Earth and still have a surplus at the present stage. The planet with the highest similarity to Earth is Kepler 452b. It is located a little further away, 1,600 light-years away from us, with an orbital period of 384 days. Its volume is 1.6 times that of Earth and has been identified as having oceans and an atmosphere in the habitable zone. Kepler 452b is considered a planet that is fully equipped with the conditions for life to be ready to live. Most importantly, astronomers have not detected a sudden increase in carbon dioxide in its atmosphere. This shows that the planet has not yet developed an industrial civilization. If there is life, it is still in its infancy and does not pose a threat to life. O humanity, in the observable universe, with a diameter of 93 billion light-years, astronomers have discovered 2,000 billion galaxies, each galaxy. There are hundreds of billions of stars, and each star has at least one planet orbiting, so even if the probability of alien civilizations existing is only once was 1,000. The number of alien species in the universe will be as many as the number of super-Earths, even more than the total population on Earth today. The Drake equation used to calculate the number of alien civilizations shows that after considering factors such as star-type distribution, habitable zone probability of planets like Earth, and the influence of the large filter in the theory of evolution in the galaxy, there are at least 10 alien civilizations with technology far beyond that of humanity or similar. However, due to the distance of tens of thousands of light years, we cannot communicate with them. It can be affirmed that any civilization with technological capabilities will actively send signals to the outside. But these signals may be like the Voyager 1 spacecraft that has yet to escape the solar system, or the electronic coverage of only a few dozen light years or less is not enough to cover a large area in the universe unless an alien civilization with superior technology appears using spacecraft to scan the entire galaxy. Otherwise, in the near future, before humanity grasps technology beyond the speed of light, we will hardly detect traces of alien civilizations in the galaxy. In theory, electromagnetic waves are a medium that is easily interfered with in long-distance communication of high-tech civilizations. So it is highly likely that they will not use neutrinos, and gravitational waves are the best choice for cosmic communication. However, their transmission speed is only equal to the speed of light and current devices. To detect gravitational waves are still very primitive, and can only detect gravitational waves from collisions between black holes and neutron stars. Gravitational waves that can actually be used for communication are not possible. Discovered the star Betelgeuse located on the left shoulder of the constellation. Orion is a red supergiant that can explode at any time. Its radius is more than 1,000 times that of the Sun. If it explodes, the night sky on Earth will be as bright as dusk for half a year in history. In the year 1054, astronomers observed a supernova explosion. They described that its light was so bright that people could read books at night without a lamp, and it lasted for several months. A few hundred years later, astronomers discovered the Crab Nebula is the remnant of that supernova explosion. However, the star Bet is much larger in volume. If it replaces the position of the Sun, the 4 inner planets, including Mercury, Venus, Earth, and Mars, will be swallowed by it, and Jupiter will become the closest planet to it. Although its mass is only more than 20 times that of the Sun, in the next few 100,000 years, it will run out of thermonuclear fuel and eventually explode as a supernova, releasing the same amount of energy with the total energy of several million years ago. If there was an alien civilization in the Andromeda Galaxy observing the Milky Way, they would see a bright spot on our Orion arm. The light from this bright spot would take 640 years to reach Earth. This means Bet may have exploded, but we have not received the light signal. In other words, if we see the light from the explosion of Betelgeuse, it means it exploded. 640 years ago, 2 space telescopes, the Hubble and the James Webb, along with ground-based observatories, are still periodically observing Betelgeuse, recording its brightness changes in recent years. It has been dimming and brightening constantly, showing that it is in the final stages of evolution. Inside this star is extremely unstable. Maybe in the near future, we will witness its explosion. The good news is, it is very far away from Earth. 640 light-years enough to reduce its radiation intensity, and only visible light remains when it reaches Earth. If it was only 6.45 light-years away from Earth, the powerful radiation of the explosion could even melt the ice on Pluto, and all human exploration equipment would be destroyed in the storm of discharge. Life on Earth would be severely affected. In the history of the Earth, several small-scale extinctions have left traces in the geological layers. The characteristic radiation traces of supernova explosions have led biologists to believe that over the past billions of years, the Earth has actually been repeatedly swept by radiation from supernova explosions. Life has therefore evolved through many cycles, following the evolutionary model of stars. Massive stars like Betelgeuse will leave a white dwarf after exploding, while the remnant of the star will form a giant nebula. If this nebula is large enough, it may collapse again in the future and form a smaller star known as a second-generation star. Our solar system was also born from the remnant of a supernova explosion long ago, 4,600,000,000 years the Earth, and we are essentially fragments from these stars. We are intrinsically bound to the stars, and the universe is one of the most powerful energy release phenomena in the universe. Some scientists believe that in the future, we may use the energy from supernova explosions to make interstellar travel even simultaneously. Detonate multiple stars to transmit information on a cosmic scale. Recently, astronomers have discovered an asteroid about 100 meters in diameter, called 2024 IR4, approaching the Earth and is expected to collide with the Earth in December. Music 2032. The most famous asteroid impact event in history is the Cretaceous extinction event 66 million years ago, when an asteroid about 10 kilometers in diameter hit the present-day Yucatan Peninsula of Mexico, causing a global catastrophe. The impact led to the extinction of species such as the sauropod dinosaurs, land, flying, and marine reptiles, completely changed the Earth's ecosystem. However, this is not the only mass extinction event in the history of the Earth. The end Permian mass extinction event, about 250 million years ago, was even more severe, when about 96 pH of marine species and 70 pH of terrestrial species disappeared. Although the cause of this event is still unclear, it is hypothesized that an asteroid impact could be one of the main factors. In theory, if the asteroid 2024 Y4 hits the Earth and falls into the ocean, it will create a tsunami hundreds of meters high, destroy coastal cities and infrastructure. If it hits land, it will cause major fires, earthquakes, and volcanic activity. Dust and ash from the impact will block out sunlight, causing global temperatures to plummet. Agriculture will collapse, famine will spread, and human civilization may fall into a state of prolonged chaos, even facing the risk of survival. However, after all, this is just one asteroid with a diameter of 100 meters. Its power is not enough to cause mass extinction, and currently, humanity is not without defense capabilities. Currently, scientists have proposed many solutions to deal with it, mainly destroy the asteroid or change its orbit. The first method has not been tested, but the test to deflect the asteroid orbit was successful in 2022. NASA, in the DART mission, has succeeded in using a 610 kg impactor, moving at a speed of 6.5 kilometers per second, to hit an asteroid, finally reduce the orbital period of the asteroid, Dimorphos, 32 minutes, far beyond the initial prediction of 73 seconds. This result shows that even small changes in orbit can effectively prevent disaster. Of course, if the target is a giant asteroid with a diameter of tens of kilometers, like the asteroid that caused the extinction of the dinosaurs, then using the probe to collide will not be able to deflect its orbit. In that case, it may be necessary to soft land on the surface of the asteroid and place a nuclear bomb to destroy it. According to the classification of the level of cosmic civilization, in about 200 years, human civilization may master controlled thermonuclear technology, exploit all resources on Earth, build cities on moons, Mars, and in space. By then, the threat from asteroids will become insignificant. Currently, astronomers are focusing on strengthening the asteroid monitoring network to improve early warning capabilities. Just in the next few hundred years, no asteroid with a diameter of tens of kilometers or hundreds of kilometers hits the Earth. Then human civilization can become a multiplanetary species, greatly improving the ability to survive in the universe. Then we will leave the solar system and expand into the range of the galaxy, unless we encounter alien civilization. Human civilization has the ability to last tens of thousands of years, or even longer. In the early 1930s, astronomers saved about the supernova. They realized that a supernova can release as much energy as the sun releases in billions of years in just a few days. But they did not fully understand the principle behind this phenomenon. Scientists were looking for an explanation for how a star can explode and why a supernova releases such a huge amount of energy. However, no one could understand this phenomenon. At that time, two astronomers, Walter and Fritz Zwicky, came up with a groundbreaking idea based on the neutron, a newly discovered elementary particle. At that time, they suggested that a supernova is not simply an explosion, but the process of the core of a star collapsing completely on itself due to extremely strong gravity. The result of this process is a supernova explosion. After the supernova explodes, it will become an extremely small and extremely dense neutron star. The matter of this neutron star will consist of pure neutrons according to Walter and Zwicky. After the supernova explodes, a neutron star is formed, and its diameter will be only about 10 to 20 kilometers, very small. However, the mass of this neutron star is predicted to be larger than the Sun. This shows that the neutron star has an extremely high density and such an extremely strong gravitational force. Walter and Zwicky predicted the theory of the existence of neutron stars after a supernova explosion. However, the hypothesis of these two scientists was too advanced for the time, because neutrons were only discovered in 1932. So the concept of a celestial body made entirely of neutrons was not accepted by the scientific community at that time. Furthermore, the two also predicted that the sound neutrons they theorized would not emit light like other normal celestial bodies. This meant that searching for neutron stars with telescopes was very difficult, and therefore it was impossible to prove the existence of neutron stars through observation. So the hypothesis of Walter and Zwicky remained a pure theory. The hypothesis of the two was forgotten because there was no evidence until the 1960s. After that, many scientists predicted that neutron stars would exist super-fast spinning. Pula. However, until the 1960s, scientists had not found any signs of sound. Neutrons at that time, astronomers were studying quasars, the brightest and most energetic objects in the universe. At that time, they were developing methods to measure the position of quasars more accurately. Anthony Hash, an astronomer at Cambridge University, was also one of the researchers of quasars. He and his graduate student, Jocelyn Burnell, worked at the Mullard Radio Observatory in Cambridge. At this time, Burnell, under the guidance of Professor Hush, was responsible for operating the telescope and analyzing the data. She analyzed about 29 millimeters of data every day. About 2 months after starting to analyze the data on August 6, 1967, she discovered a radio signal repeating regularly with a distance of 1.33 b seconds. However, this signal did not come from the Earth. It was always emitted from the same location outside the Earth, and not a telescope error or an instrument error. This was clearly a signal coming from space, and it appeared regularly with a distance of 1.33 b seconds. The two people hoped that this signal could come from an alien civilization, but they also thought that it could be. This was a natural phenomenon in the universe, and they continued to investigate with all possibilities. They joked that this signal was alien and nicknamed it Little Green Man on December 21, 1967. The two people discovered a second signal with almost the same characteristics. Finding a second signal that was almost identical showed that this was not a signal from an alien civilization, but a natural phenomenon. There was also research by other scientists. In 1968, Richard Lovelace's team observed the center of the Crab Nebula using the Arak Observatory and discovered a pusa at the center of the nebula. This pusa rotates with a period of 33 centimeters, an extremely fast speed. In 1933, Walter and Zwicky predicted the theory that after the supernova explosion, a neutron star would remain. They classified the rapidly rotating neutron star as pusa, thanks to the work of Huey Wish Burnell and Lovelace's research group. The existence of pusa, which was only a theory, has been completely proven. The scientists who predicted the existence of sound neutrons and pusa by just theory and calculation were amazing, and the scientists who actually observed them were also amazing. In Warren, Anthony was awarded the Nobel Prize in Physics for discovering pusa. However, Jocelyn Bell Burnell, who operated the telescope and analyzed the data to discover pusa, was disqualified from the prize. Many astronomers, including Fred Ho, criticized Byrne for not being chosen as a co-author of the prize. Why was her work so underrated? Was it because she was a woman that she was not awarded the Nobel Prize? Or because she was just a graduate student? Anyway, she played a key role. Not awarding her is unreasonable. On the other hand, some people think that no matter how important her role is, the direction of research is still decided by Professor Highwas on this issue. Burnell expressed that she did not feel resentful for not receiving the Nobel Prize, but even respected the decision of the Nobel Committee. Fortunately, thanks to her active research activities, later she received many prestigious awards, such as the Oppenheimer Prize, the Herschel Medal of the Royal Astronomical Society, the Tinsley Prize of the American Astronomical Society, and was knighted by the Queen of England later. Burnell said that instead of the Nobel Prize, she received many other awards and had the opportunity to attend many parties. That is also good, really. A great example we have learned about the story of astronomers, theoretical prediction, and successful observation of the existence of pusa. Now we will learn about pusa in detail, starting from how they are formed. Imagine there is a star with mass 1 to 8 times the size of the Sun. This star gradually evolves into a red giant and then a white dwarf. Take our Sun as an example. In about 5 billion years, the Sun will become a red giant. At that time, the Sun will swell up to more than 100 times larger than it is now, swallowing about Mercury, Venus, and finally the Earth. After becoming a red giant and swelling up, the Sun will carry out a nuclear fusion reaction with helium as fuel. When the helium is burned out, the outer shell will be pushed into space, leaving only the central core, which is the white dwarf. Our Sun will become a white dwarf in about 5 to 7 billion years, with a diameter of about 13 to 15,000 kilometers, equivalent to the size of the Earth, or slightly larger in volume. The Sun will shrink 1,000,000 times when becoming a white dwarf. It is amazing that a giant star like the Sun can become so small. So what about a star with a mass 8 times that of the Sun? In this case, the star will go through another process. This star will initially perform a fusion reaction with hydrogen as fuel. After burning all the hydrogen, it will burn helium, then carbon, and finally iron. During this process, the core of the star will become hotter and denser, becoming a giant superstar. When iron is created, the star will no longer be able to perform a fusion reaction with iron because iron is too stable. Finally, when the fuel is exhausted, the core of the star will collapse rapidly due to the extremely high temperature and extremely strong gravity. The outer shell of the star will be shot out in a terrible explosion, releasing a huge amount of energy. That is a supernova. When the supernova explodes, the elements that have accumulated in the core of the star will spread throughout the universe. These heavy elements will become the raw materials to form new stars and planets in the universe. After the supernova explodes, only the core of the star remains. If the mass of this core is between 1.4 and 2.5 times the mass of the Sun, it will become a neutron star. If the mass is larger, it will become a neutron star. It will become a black hole. The diameter of the neutron star is only about 10 to 20 kilometers. However, the mass of the neutron star is larger than the Sun. The gravity of the neutron star is extremely strong enough to change the atomic structure. The core remaining after the supernova explosion is mainly made of iron, along with some other elements such as nickel and cobalt, due to the gravity and the extreme pressure. The electrons are separated from the nucleus and move freely, called free electrons. The atoms only have the nucleus in a state of complete ionization. An interesting thing happens. The pressure and the extreme gravity of the neutron star causes the free electrons to collide and combine with the nucleus, in which protons turn into neutrons, and neutrinos are released. This process continues. The electron disappears. Protons turn into neutrons, and the number of neutrons increases. Finally, heavy atoms like iron in the core stir. All turn into neutrons, creating a super-dense and super-heavy neutron star. We have learned about the process of neutron star formation. So what is Pusa Pusa? Is a type of neutron star that meets the following conditions. First, it must rotate extremely fast with speeds that can reach tens to hundreds of revolutions per second. It must have an extremely strong magnetic field, emitting strong electromagnetic rays, such as radio waves, gamma rays. Third, these electromagnetic rays must be observable from Earth. When all three of these conditions are met, Pula will emit regular signals like a lighthouse guiding the Tau at sea. The reason Pusa spins fast is due to the law of conservation of angular momentum. Just like an ice skater, when pulling in his arms will spin faster. Neutron stars do the same. When a supernova explodes, the star is already spinning, and as it shrinks in size, the rotation speed increases to conserve angular momentum. NASA and ES Hubble Space Telescope was launched into orbit on the Toy Discovery spacecraft on April 24, 1990. Hubble is the first space telescope in the past 34 years since being launched into space. It has brought a new perspective on the universe, sending back data and images that have changed scientists' understanding of the universe as well as public awareness of it. Hubble's discoveries revolutionized nearly every field of current astronomical research, from planetary science to cosmology. The Hubble Deep Field and its images are truly beyond imagination. In this video, we will review some of the greatest scientific discoveries of the Hubble during its more than 3 decades of operation. The first and most memorable result is the famous Hubble Deep Field image. This is a prolonged observation of a specific area of the sky to detect faint objects by collecting light from them. Over a long enough exposure time, these images were later published and fascinated both scientists and the public when thousands of galaxies were recorded in just one single photo, causing widespread amazement and curiosity around the world. The Hubble Deep Field scene, published in 1996, included an area of the sky only 1/12 the width of the Moon, in which the Hubble found nearly 3,000 distant galaxies, followed by the Hubble Ultra Deep Field image published in 2004, was the deepest portrait of the visible universe ever achieved by mankind. In 2004-2012, Hubble Extreme Deep Field image is an impressive combination of over 2,000 exposures into one image. The resulting image has amazed astronomers by studying the thousands of galaxies recorded in these deep field observations, including some of the most distant primordial galaxies. They have learned more about the early universe. Most of these early and distant galaxies have not yet formed stars, and are also characterized by atypical shapes as they appear smaller and more irregular than those closer to us. This is seen as clear evidence that galaxies are formed through the merger of smaller objects. The Hubble Frontier Fields Observational Program has harnessed the power of large galaxy clusters to the full potential of the Hubble Space Telescope. The Hubble's high sensitivity and resolution allows it to observe faint and distant gravitational lenses that are difficult to detect. With ground-based telescopes, gravitational lenses are phenomena caused by extremely large masses such as the cores of galaxies. Galaxies or clusters of galaxies exert their strong gravity, which distorts the space around them, and light from distant objects passing through this curved space is deflected from a straight path, as if passing through a lens. Hubble can observe in detail circular arcs shaped like bananas. One of the main effects caused by gravitational lensing, with the distorted image of the background object in the background. An important result of gravitational lensing is magnification, which allows us to observe many distant and faint objects that are otherwise invisible. Hubble takes advantage of this magnification effect to study beyond the sensitivity of the primary mirror. 2.4 mm in diameter shows us the most distant galaxies ever discovered. Hubble's observations of the lensing effect have also given us a glimpse of the universe. One of Hubble's core original purposes was to determine the expansion rate of the universe, which astronomers call the Hubble constant. This value is an essential ingredient needed to determine the age, size, and fate of the universe. Before Hubble was launched, the value of the Hubble constant was not known precisely, and calculations of the age of the universe range from 10 billion to 20 billion years. Now, astronomers using data and observations from the Hubble Space Telescope have refined estimates of the current expansion rate of the universe and are working to make it more accurate. Hubble's refined distance values have helped determine the age of the universe to be 13.8 billion years while improving Hubble constant measurements. Hubble Space Telescope data also aided in the development and use of the cosmic distance scale, an important scientific tool used to measure precise distances to galaxies near and far the Earth. To do this, astronomers use Hubble to measure the distance to a type of oscillating star called a variable star. It is used as a benchmark. When CF stars are calibrated, astronomers go further out into the galaxy to nearby galaxies to use the instruments. Other reliable measurement supernovae stars exploding with the same brightness, astronomers use X stars to calibrate the relationship between the absolute and apparent brightness of supernovae, a relationship that depends on the distance of the host galaxy from ours. We detect supernovae in galaxies hundreds of millions of light-years away, providing a powerful tool for calibrating redshifts at greater distances than is possible with C-fed stars. However, scientists found that supernovae are at higher redshifts and fainter than predicted when assuming the rate of expansion of the universe is constant, meaning they are farther away. These observations have helped astronomers determine the rate of expansion of the universe over time. Surprisingly, the data showed that the universe is not expanding at a constant rate, but is instead accelerating. Many scientists believe this acceleration is due to something called dark energy, which accounts for about 70% of the entire universe. By observation, how dark energy changes over time, astronomers hope to better understand it and how it might affect the future of the universe. This telescope has also conducted surveys and developed new methods to search for clues about dark matter, another mysterious substance that makes up about 27% of the universe. Astronomers use Hubble to create maps of normal visible matter from which they can determine the large-scale distribution of dark matter by studying how its gravitational presence distorts light in images. Hubble also lifts the veil of mystery surrounding the cosmic monsters that lurk at the centers of most galaxies. These are supermassive black holes using spectroscopic observations. Hubble has peered deep into the cores of galaxies and found that the stars there move in very tight orbits at enormous speeds. This strange behavior suggests the presence of an incredibly large gravitational field that could only be produced by a supermassive black hole. Hubble has provided evidence the first certainty of their existence. Today we know that at the center of almost every galaxy, there is a black hole. Another phenomenon that Hubble instruments have observed over the years are distant quasars. These are powerful jets of energy emitted from extremely bright galactic centers. The energy from a quasar is immense, and they are often thousands of times brighter than the Milky Way in 1996. Hubble's 100,000th image was of a quasar 9 billion light-years from Earth. More recently, Hubble discovered the brightest quasar ever seen in the early universe. Hubble has revolutionized planetary science in many ways through its precise observations of our solar system. Hubble has tracked activity on Jupiter and its moon Io in 1994. Hubble also witnessed a comet impacting the planet's surface. Hubble has also observed auroras on several planets in our solar system. We include Saturn and Uranus. Data from this telescope was also used to study the origin of the smallest known moon orbiting the planet Neptune, called Hippocamp. In 2013, Hubble provided the first observational evidence of water vapor spewing from the icy surface of Jupiter's moon, Eurasia near the South Pole. The telescope also collected observations of some special interstellar visitors. In 2018, Hubble studies OMA, the first interstellar object discovered in the solar system in collaboration with other ground telescopes. It was determined that the object was likely a comet and was moving away from the Sun faster than previously thought. In 2019, Hubble provided astronomers with the sharpest and best image ever of the interstellar visitor comet 2 Borisov, believed to come from another planetary system. In our galaxy, Hubble's high resolution has also played an important role in studying the formation regions, stars both in the Milky Way and other galaxies, and its infrared observing capabilities have allowed Hubble to peer through the dense clouds of dust and gas in those regions. The end of a star can be as beautiful and exciting as its birth. Hubble has observed sun-like stars as they come to the end of their lives in the form of planetary nebulae and massive stars that undergo explosive deaths as supernovae. By studying them at different times in their lives, Hubble has helped us paint a more complete picture of stars, the building blocks of the galaxy. Although not one of its original scientific goals, Hubble has also established itself as an exoplanet explorer, especially through the study of the atmospheres of extrasolar planets. The chemical composition of a planet's atmosphere leaves a unique fingerprint on the starlight that passes through it. By studying the Orion Nebula, Hubble has made the astonishing discovery that at least half of the stars in this region are surrounded by rotating disks of gas and dust, the raw materials needed to form planets in 2016. Hubble first analyzed the dry atmosphere of a super-Earth 40 light-years away in 2019. In an exciting discovery, the telescope's data was used to detect water vapor in the atmosphere of a super-Earth located in the habitable zone. K2-18 is 8 times the mass of Earth, and at the time of its discovery, it was the only planet orbiting a star outside our solar system known to have both water and temperatures that could support life before Hubble. Did this work, only one planetary system had ever been confirmed. Hubble's observations have shown us that planets are forming around more stars than previously thought, raising the possibility that life may exist somewhere out there, and in the future, Hubble may find signs of life. In one of these fingerprints is a prominent international collaboration between NASA and ESA Hubble Space. Telescope will continue to operate as long as its components remain in good working order and provide good service to the scientific community. Its unprecedented capabilities have made Hubble one of the most powerful scientific instruments ever created by man, and certainly the most beloved by the public. How spectroscopy works. and what studying light can reveal about the universe. Astronomers are using D-stellar spectroscopy to study exoplanets in the search for life. This video will explore how spectroscopy works and how it supports valuable research with NASA and ESA Hubble Space Telescope, including groundbreaking studies of exoplanets. While images of the universe excite and inspire the public, spectroscopy is a fundamental tool that astronomers use to study the universe. Hubble's spectrometers provide the data scientists need to analyze the matter that makes up stars, nebulae, galaxies, and atmospheres. The planet's Hubble is equipped with two spectrometers. The Space Telescope Imaging Spectrometer, installed in 1997, and the Cosmic Origins Spectrometer, installed in 2009. Any object that absorbs or emits light can be studied using a spectrometer to determine characteristics such as temperature, density, chemical composition, and velocity. As the light travels into the spectrometer, it is separated by a dispersive optical element into different components or wavelengths. For study, this element acts like raindrops, scattering light to form a rainbow. The scattered light is then focused onto a sensor and displayed as a spectrum. Astronomers can analyze the spectral pattern to decipher the atoms and molecules present in the light source. This helps them understand the different physical and chemical properties of that light source. In this way, images from Hubble tell us what an object looks like, while spectral data tells us what it is. What is it made of? The exoplanet spectrum is one of Hubble's most important contributions to astronomy, placed in orbit around the Earth. Hubble is not obstructed by the Earth's atmosphere, which absorbs light from the outside. The telescope is also equipped with sensors sensitive to light from the outside. Spectroscopy has been the basis for many important discoveries from Hubble. For example, Hubble has recorded the signature of a black hole, and its spectral observations have left a mark on the distant universe, using light from quasars to help astronomers study the raw materials that make up galaxies. The spectrum has also become an essential tool in Hubble's study of exoplanets. This is especially significant because when Hubble was launched, planets outside our solar system had not yet been discovered, thanks to its spectrometers. Hubble has provided the first direct detection of the atmosphere of a planet orbiting an extrasolar star, and has detected organic molecules in the atmosphere of a planet. In this way, spectral studies of the atmospheres of exoplanets transiting their host stars have been carried out by astronomers at the Hubble Pioneer. These exoplanets are studied as they pass in front of their host stars, as observed from Earth, as chemicals in their atmospheres leave characteristic traces in the spectrum by filtering out certain wavelengths of starlight. In the search for signs of life, astronomers are looking for characteristic spectral traces. Each chemical element in the atmosphere of an exoplanet will block light from the host star at certain wavelengths, creating absorption lines in the spectrum of the star. This is how astronomers can determine the presence of atoms and molecules, specifically some of which are important prerequisites for life, such as methane, water, oxygen, ozone, and others. For example, during the total lunar eclipse in January 2019, astronomers used the Hubble to perform a special spectroscopy experiment to test how they will observe Earth-like planets orbiting other stars in the future to search for life. The perfect alignment of our planet with the Sun and Moon during a total lunar eclipse mimicked the geometry of a terrestrial planet passing in front of its host star. In this innovative study, Hubble used the Moon as a mirror to reflect sunlight that had been filtered through the Earth's atmosphere. Spectral observations of this light detected signs of ozone in the Earth's atmosphere, an important prerequisite for the existence and possibly the evolution of life as we know it on Earth to date. Astronomers have used Hubble to observe the atmospheres of gas giant planets as they pass in front of their host planets. However, terrestrial planets are much smaller, and their atmospheres are also thinner. So analyzing these signs is much more difficult, which is why researchers will need much larger space telescopes than Hubble to collect the faint signal. As starlight passes through the atmospheres of these small planets during transits, a larger light-collecting area would allow for more efficient detection of these faint signals. The James Webb Space Telescope, a collaborative effort between NASA ESA and CSR. The ability to penetrate deep into the atmosphere of an exoplanet to detect mean and oxygen if they are present not only aids in spectroscopic observations of exoplanets. This new observation also pioneers new spectroscopic studies across all areas of astronomy. Our knowledge of exoplanets has grown rapidly in recent years. Astronomers have discovered numerous worlds beyond our solar system, even deducing information about their sizes, temperatures, and atmospheres. But how can scientists learn these details about planets that exist at such great distances from us? One way scientists do this is by discovering exoplanets from the transit method. Exoplanets raise intriguing questions from the possibility of Earth-like worlds to alien life. But pursuing the answers to these questions is no easy task. Exoplanets barely emit visible light of their own and orbit stars at great distances from Earth, making them extremely difficult to observe. Transits provide one of the best opportunities to study exoplanets. This is a phenomenon that occurs when a planet passes between its host star, and Earth, temporarily, reduces the apparent brightness of the star. The length of time and magnitude of the change in light intensity gives astronomers clues about the planet's size and orbit. Smaller dips in light levels just before or just after. A transit can be a sign of a transiting satellite, can even reveal what the planet is made of. The small amount of light that passes through the planet's atmosphere interacts with atoms and molecules, where the light then carries information about them, which scientists can use to make inferences about conditions such as temperature, chemical composition, and formation history. However, this method has limitations. Transits only occur if a planet's orbit actually passes between its host star and Earth, meaning its orbit must be on the edge facing us. This is only true for a small fraction of planetary systems. Even when transits do occur, they are infrequent and last for a relatively short period of time, making chance observations very unlikely. Transits also tend to detect larger exoplanets that are closer to their host star. These block out more light, creating a larger dip in brightness, making detection easier. So transits cannot represent the full diversity of worlds out there. There can even be false positives. Sometimes the dip in brightness is not caused by a planet, but by another phenomenon. For example, a star passing in front of another star in a star system. Despite these limitations, the transit method has helped discover countless other worlds, thanks to the huge number of stars and planets in the universe, and the advanced technology used to find them. The Hubble Space Telescope is a major milestone in this field. Hubble has performed the first atmospheric study of Earth-sized exoplanets, captured the first image of an exoplanet in visible light, and detected the first organic molecule in the atmosphere of an exoplanet. However, these amazing discoveries have pushed Hubble to its limits to explore deeper into these worlds. This far away, we need more powerful telescopes. The James Webb Space Telescope will take this technology to the next level. The James Webb observes the universe in the infrared with unprecedented sensitivity. This is especially beneficial for studying exoplanets because the molecules in their atmospheres leave many of the most important signals in the infrared. Specifically, these wavelengths can help us find habitable planets, planets with the right conditions to maintain liquid water, emit thermal radiation that peaks in the infrared. The James Webb's sensitivity to these important wavelengths will certainly help uncover more mysteries about exoplanets and maybe even find life somewhere in the universe. It's been 3 years since NASA's James Webb Space Telescope was launched on a mission to explore the history of the universe. The James Webb embarks on a journey back to the birth of the universe. Imagine someone saying, "Let's invent a telescope that can look backwards about the Big Bang and through the depths of time to help scientists understand how planets, stars, and galaxies form, what happens when they die." It's been a fascinating journey. Here are some of the remarkable images the James Webb Telescope has captured. Music ARP 107 is a pair of colliding galaxies located 465 million light-years from Earth, in the constellation Leo Minor. This image captures a scene spanning about 400,000 light-years. The spiral galaxy is 6 times more massive than its elliptical companion. In ARP 107, 2 galaxies. In the early stages of a merger on the left, a smaller elliptical galaxy facing the larger spiral galaxy on the right, their interaction originated from an off-center collision, when the smaller galaxy hit the spiral galaxy from the side. A few 100 million years ago, these 2 bright regions are where star formation is taking place. Galaxy collisions can be triggering the birth of new stars as interstellar gas is compressed. The spiral galaxy in ARP 107 has an unusually bright core. This brightness is due in part to the supermassive black hole at the center, which is devouring surrounding matter such as gas and dust. As this matter falls into it, it heats up and releases a huge amount of energy, causing the galaxy's core to glow brightly at longer wavelengths. We can observe this bright spot of light, a clear sign of the activity of the black hole as it is sucking in matter. A fragile bridge stretches between the 2 galaxies, consisting of a mixture of stars and gas as a result of their interactions. This stream of matter is pulled from both galaxies as they interact, creating a visible link, emphasizing the violence of this encounter. This new image from the James Webb Space Telescope combines near-infrared and mid-infrared light. But each wavelength was also captured separately. In the mid-infrared, the galaxy's bright core stands out, while the bridge of matter connects the 2 galaxies. Vanishing Galaxy reveals each wavelength, offers unique perspectives on the structure of this galaxy pair. ARP 107 is striking, as it shows the dramatic effects of galactic interactions with a distorted spiral galaxy, connected by a bridge of matter to another galaxy, providing insights into the processes that drive galactic evolution. As we look across the universe, 2 galaxies emerge from the darkness, entwined in a gravitational dance. On the right, NGC 2207. The larger galaxy in the T-pair exerts its gravitational pull on its smaller neighbor, IC 2163 on the left. Although not yet merged, this close encounter has already begun to stretch and twist their spiral arms, creating extensions of nebulous gas streaks stretching into space, marking the early stages of this cosmic interaction. These 2 galaxies are located 114 million light-years from Earth. NGC 2207 has a diameter of 143,000 light-years, while galaxy IC 2163 is 10 billion light-years, across almost the same as our own galaxy. What makes this image even more mesmerizing is the combination of data from 2 of our top telescopes. Webb's mid-infrared view captures the star formation going on right now, while Hubble's visible and infrared light reveal young stars that have just exploded into life. It's like we're looking through 2 windows in time, looking over each other to give a richer look at the evolution of these galaxies. Notice the long, glowing blue clumps littering the image. These are regions where stars are forming at a rapid rate. Hubble highlights these stellar nurseries, while Webb's mid-infrared view overlays a ghostly red glow illuminating the dusty regions surrounding the stars. Together, these views give us a mystical look at galaxies encased in glowing dusty shells. These are star factories that create new stars at a rapid rate into 10 times our galaxy. Each galaxy has seen many supernova explosions. Giant explosions in the universe leave their mark, releasing new elements into space. These powerful explosions may have created new directions for star formation, showing up as bright blue patches scattered across the image. Those deep red streaks. They may be shockwave impact areas. Areas where the matter of the two galaxies collide and compress, creating a chilling reminder of their violent interaction. This area is called Feature Y, a powerful star. Forming center, located in the outer arms of NG 2207. Brighter than the core of the galaxy. Although it looks dusty and quiet in visible light, it is actually the most active region. A miniature starburst region, where stars form at an incredible rate, and traces of ancient supernova explosions will still echo through space in just a few million years. Two galaxies. These galaxies will merge their fiery tryst, will end in the formation of a single galaxy. This image brought to you by the Webb and Hubble collaboration exposes galactic interactions and star formation in chilling detail, giving us a rare glimpse into the dark mysteries of the universe. Deep within a gas cloud, the once hidden features of this young and mysterious protostar have been revealed by the James Webb Space Telescope. Protostars like this one, still encased in a dark cloud of dust and gas, have a long way to go before becoming full-fledged stars. At just 100,000 years old, it is in the earliest stages of star formation and has yet to generate its own energy through the nuclear fusion of hydrogen. Its shape, though mostly spherical, is also unstable. It resembles a small, hot and puffy cloud of gas with a mass between 20 and 40 pH. The mass of our Sun. Its distinctive shape, its hourglass-like appearance, has helped provide insight into the beginnings of a new star standing on the threshold of a long and tumultuous life. Ahead. The most prominent features of this region, with its vibrant blue and orange clouds. In this color-infrared image, depict the cavities created when material ejected from the forming star collides with its surroundings. These fiery clouds are located in the Taurus star formation region, which can only be seen in infrared light, making it an ideal target for two of the Webb's powerful scientific instruments, the near-infrared camera and the general infrared instrument. It is the layers of dust between the Webb and the clouds that create these colors. The blue areas show where the dust is thinnest. The thicker the dust, the harder it is for blue light to escape, creating dark orange areas as it continues to gather mass. Its core will gradually compress and move closer to a stable state of nucleosynthesis. The surrounding molecular cloud, made up of dense layers of dust and gas, is drawn in. The center, where the protostar resides as matter falls into it, swirls around the center, creating a dense disk of matter called an accretion disk that feeds the protostar. As its mass increases and becomes more compact, the core temperature will rise eventually, reaching a threshold for nuclear fusion to begin. The Webb also revealed that filaments of molecular hydrogen were severely disrupted as the protostar ejected matter away from it. The old ones collided, and this turbulence inhibited the formation of new stars, which would have appeared throughout the cloud as a result. The protostar dominated the space, attracting most of the matter towards it. The James Webb Space Telescope has captured two new images of the formation region. NGC 604, located in the Triangulum Galaxy 2IU light-years from Earth. The brightest within these clouds of gas and dust are over 200 of the hottest, most massive stars, all of which are in the early stages of their lives. The largest of these stars may have more than 100 times the mass of our Sun. Using the Webb's powerful near-infrared camera, the most noticeable features are the bright red bands and clusters of emission extending out from what appear to be voids or giant bubbles in the nebula. Winds from the brightest and hottest young stars have created these cavities. while the ultraviolet radiation ionizes the surrounding gas. This ionized hydrogen gas appears as a ghostly white and blue glow as you move further away from the immediate voids of dust. The deeper red hue indicates the presence of molecular hydrogen. This cooler molecular gas may be the fuel for future generations of stars. Forming the Webb's General Infrared Instrument allows us to see a new view of the diverse and dynamic activities in this region. In the infrared image of NGC 604, the number of stars is clearly visible. This is because the hot stars are dimmer at this wavelength of light, while the cooler clouds of gas and dust are glowing brightly. Some of the stars that appear in this image are in the neighboring galaxy, which are supergiants, red giants, stars with low surface temperatures, but very large, hundreds of times the diameter of our Sun. How stars are born and how they interact with their surroundings are two big questions in astronomy today that are being actively studied with the Webb telescope. In this new image, the Webb is showing us parts of the story of X's formation that we've never seen before, revealing more about the universe and our place in it. Music.